Hello friends, in this session we are going to discuss about the open channel hydraulics. In the last class we discussed about the flow in pipes where the water will flow in a pipe due to pressure difference. That is a high elevation or high pressure to your lower pressure, and this pressure is different created by your pump, whereas in this open channel the flow will take place due to the gravity. So before going to details, let us see what is the meaning of your open channel hydraulics or open channel. Open channel is a branch of hydraulics and fluid mechanics. It is a type of flow by gravity that is called your potential energy, or simply we can say that is elevation difference. So now let us see, this is a open channel. Water is flowing from this canal and the water is flowing from this higher elevation to your lower elevation, like the slope is in this direction. So the water will flow from the high elevation to your lower elevation. That is called your potential difference or potential energy within a conduit. Conduit means this is the section. The water will path we created to flow the water from your one place to another flows. And here in this section or in this conduit, the pressure is equals to your atmospheric pressure. So that is the pressure on this liquid surface of your water is equals to your atmospheric pressure. Whereas in this pipe flow, the pressure is more than your atmospheric pressure, more than your atmospheric pressure. So that if you make the small hole to this pipe, the water will come out and it will rise certain height. So that is a major difference. If you let us take this pipe, the water is flowing in this pipe, but it is flowing only small portion or half portion. Remaining this half is empty. So this is also a type of your open channel flow. Remaining this portion, see, this is the portion is directly exposed to your air. That is called your atmospheric air. Even this is also best example for your open channel flow, because remaining portion, this entire portion is directly exposed to the air, and here the pressure is equals to your atmospheric pressure. Even the flow is taking in the pipe. So let us see the difference between your open channel flow and pipe channel flow. So now open channel flow, the free surface present in open channel and the pressure is equals to your atmospheric pressure, that is equals to your reference pressure. So as I told you, the pressure in this open channel is equal to your local atmospheric pressure, and in this pipe flow the free surface is absent. So let us say there is no free surface in this pipe, and because the flow in pipe is taking fully, therefore the pressure is higher than your atmospheric pressure, and the flow is taking place due to only pressure drop or pressure difference. The flow is driven by only slope of your bed, that is called your elevation difference, that is called your gravity or potential energy. But whereas in this pipe flow the pressure is due to only hydraulic pressure, we call that is the difference in pressure. And the liquid surface itself represents the hydraulic gradient line. So we will discuss what is the meaning of hydraulic gradient line in next slide here. So this pressure, okay, the pressure or energy is itself represent your hydraulic gradient line, whereas in this it is a hydraulic gradient line, the total energy is joining your piezometric surface, it will indicate your hydraulic gradient line. And in this open channel flow, the uniform flow in open channel, the drop in the energy gradient line is equals to your drop in the bed. Means here water will flow from this direction, from the high elevation to your low elevation, like this. Okay, water is flowing in this direction, and the drop in this energy, drop in the reduce or high in the energy, it depends on your slope of your bed. So if bed is increases, then energy is increases. The bed is reduced, means slope is reduces, the energy gradient line also reduces. That is both are interrelation. Whereas there is no relation between your energy gradient line and slope of your pipe. Even though the flow in this pipe, if you having the high gradient or high slope, there is nothing change in your energy gradient line or hydraulic gradient line. The flow cross section is unknown, because see, if you see this is the section, here the cross section may be vary. This is a higher cross section, here the low cross section. So the cross section of this open channel may be vary or unknown. But whereas in this pipe flow, if you know the diameter of this pipe, you can simply estimate the area is pi by 4 d square, and the cross section may be uniform or vary. That depends on your pipe. But here the cross section is easily can find out. But whereas in the open channel it is little difficult. Relative roughness changes with the level of your free surface. Roughness means the contacting at bottom slope. The roughness is a little bit changes or vary with your bed or simple type of your canal or channel. The relative roughness is fixed quantity, because the water is flowing in this pipe is constant and this pipe is uniform. So what is the roughness or friction is the entire pipe is same throughout this length, and the depth of flow, discharge, slope of channel bottom and the free surface are independent. Here the depth of flow, discharge and slope, all these things in open channel are independent. The flow depth is derived from this your continuity and momentum equation. Mean flow depth, the depth of water in this. Suppose I want to estimate the depth of water, how much depth of water is flowing in this condition. So we can estimate from your continuity equation, that is called your Q is equal to area into velocity. Area is your breadth into depth into velocity. In this condition, what are the parameters? The depth of the flow, width of the flow, velocity, we can estimate in this open channel flow. The characteristic flow parameter, that is velocity, is derived from your continuity equation. Same thing. The maximum velocity occur at the little below your water surface. Means if you see this diagram, the water is flowing in open channel, the maximum velocity will occur. So this is the top of the surface, not exactly at the top of, little bit below the top of the surface. This is the most important question they will ask in the examination. Where is the maximum velocity takes place in the open channel flow? That is the not exactly on the surface, that is little bit below, that is normally 0.5 to 0.15 meters below the surface of your water. And whereas this in pipe flow, it will take in the center of your flow. This is the flow in case of your laminar, that is the maximum friction is at beds or your pipe. Similar way here the maximum friction, and this is due to, this curve is due to your resistance. We will discuss what is the velocity profile in upcoming session. And the velocity distribution is a logarithmic or power law distribution. If you see this, the equation or this curve, it varies. It is similar to your logarithmic or power law distribution. So this is varies, not exactly straight line, not like this, or not completely similar or parallel to the y-axis. It is varies little curve in logarithmic shape. So this is called your power law distribution. But whereas in the velocity distribution is parabola. So this is the parabola shape for the laminar flow only. This is the parabola for only laminar flow. The next one is your hydraulic gradient line and energy gradient line. Let us see the definition and difference between these two lines. Hydraulic gradient line is line joining the sum of pressure head. So we know that the pressure head from the Bernoulli equation, we know that pressure is density gravity plus V square by the 2G and elevation is constant. Now suppose the sum of this elevation and your pressure head. So pressure head nothing but your pressure, we know density, gravity, height. So can I write in terms of height? That is your pressure by density into gravity. That nothing but your height. This equation I am writing in this way. So now same thing, the energy gradient line is sum of your pressure head. This is the pressure head and elevation head. This is here the elevation. This head is estimated. The head is estimated by using piezometer. That is H, the water, how much depth of water is flowing in this channel, that is head. And with respect to your bottom line, this is the D. So now sum of these two is represent your hydraulic gradient line. The hydraulic gradient line is surface profile of water flowing in a, now I am drawing this all energy. Now here point section is 1. Suppose I am drawing here. So this is also HW. Now another point I am taking this point. Now this is also HW. Mean R simply head. Pressure head. This is also Z. Now I am drawing all this line. Make a straight line. This is called your profile. You can say that the profile. So this represent your the profile of your water flowing. That will indicate the piezometric head. Whereas your energy gradient line is the joining of your sum of pressure head. This is the pressure head. That is the pressure by density gravity plus depth, or we can say that is depth of flow in terms of head, as I told you here, head, and velocity head. That is called your nothing but kinetic energy. That is a V square by the 2G. Because water is flowing in the open channel with some velocity. So velocity having, you can represent in the V square by 2G. So that is the velocity head. This velocity head can be represented, measured by your pitot tube. That is, and your potential head, that is your H plus H. Now sum of this all equation, pressure by the density gravity, V square by the 2, that is your kinetic energy, and your potential head. That is represent your total or energy gradient line. So this is sum of your all these heads that represent your energy gradient line. So the line that represent the elevation energy head and the water flowing in the pipe, conduit or channel. So now can we write this, the hydraulic energy gradient line plus V square by 2G, nothing but your kinetic energy. This is your kinetic energy. So hydraulic gradient energy, that is your pressure head plus elevation head. Here the gradient mean nothing but your hydraulic gradient mean nothing but your change. That is your hydraulic loss, hydraulic head loss by how much length of the flow. Suppose the water is flowing for the long distance. So now the difference here head, okay, and here another section, this is the 1 and this is the section 2. So in this condition, the how much head loss from this entire length. So that is your hydraulic head loss by length of your flow. Similarly, energy gradient, nothing but your total head loss by length of the flow. Now let us see the types of open channel. Based on your shape, the channel has been classified your circular shape, rectangular, trapezoidal and triangular. Okay, and these channels are also be artificial channels. If you man-made, if you made this such type of channel, we can call that is your man-made, and the channel are formed by naturally. Okay, that is called your natural channels by your flow of water, like river automatically form a one shape of channel. Maybe this or any shape, rectangular or circular or triangular or some any irregular shape. So these are the called natural channels. And next one, based on your change in cross section. Okay, so now after continuously running water in this channel, the cross section may be vary. Let us see, this is the channel one type of, here the cross section means width and depth of the flow is varying. So here depth higher. So here due to the grass, due to improper maintenance of your canal, the grass and some siltation deposition takes place. So in this condition, the width and depth, anything may be vary. And so that called based on this cross section. So there are two types channel has been classified. One is your prismatic channel, second one is a non-prismatic channel, where the channel having unvarying or constant cross section. So those type of channel are called your prismatic channel. So suppose the channel are lined. Okay, this is the channel. Okay, look like your trapezoidal. So here these sides are lined and bottom are lined. So in this condition, for a longer duration, for a more year, more 10 years, 50 years, the cross section may be constant, does not vary. So this is called your prismatic channel, or example are man-made channel or line channel for the lab studies. Next one is prismatic channel. As I told you, the due to unlined channel, the due to the animal movement or anything, the channel cross section may be disturbed or may be vary. These are called your non-prismatic channel. Example are your all these things based on the boundary condition. So now let us see, based on the boundary condition, the boundary is not deformable. Okay, not deformable. That shape is rough. Magnitude is not a function of your flow depth. Even though after, if you keep this channel for a longer duration, even though now this boundary will not change. Boundary will not change for a longer period. So in this condition, the shape, the roughness may not vary. So this type of channel will call your rigid boundary. Okay, for a small duration, for a season, for a 3 month, for a 5 month, for a 6 month, this type of boundaries may be vary, may be change. So that condition we call the mobile boundary channel or natural channels. So in the rigid channel, the degree of freedom is 1. The most important, the degree of freedom in the rigid channel is 1, because here depth of flow varies with the space and time. That depends upon only nature of flow only, because after long time the shape is not going to change. So this not be deformable and it will be constant. Only in this condition, only the flow or depth will depend upon your nature of the flow. But whereas in the mobile boundary, so all these things, the depth of flow may be vary, because some water, some soil may be deposited in this condition. So in this condition, the bed depth may be changed. So bed width may be changed, bed slope may be changed, a layout, shape, anything may be undergoes the change. In this condition, how many parameters are there? 1, 2, 3, 4. So in this condition, the degree of freedom of these mobile boundary is 4, whereas in the rigid boundary is 1.